Method isn't metaphysics. The structure of inference and its consequences for science. Or why science can't disprove free will and a bunch of other stuff. Certain propositions cannot be established through scientific methods not because of practical limitations in current technology or resources, but due to the formal structure of reasoning itself. Reasoning derives conclusions from premises. The premises are not established by the inferences they support. For example, if it is raining, then an umbrella is needed. It is raining, therefore an umbrella is needed. This derivation relies on the premise that rain requires an umbrella, but it doesn't establish that premise, it begins with it. Scientific reasoning is no exception. It derives conclusions from assumptions that cannot be demonstrated within the system they form. Propositions are called scientific either because they're supported by empirical investigation consistent with the scientific method, or because they're presupposed by scientific inquiry. An easy example is law-governed regularity. Scientific reasoning relies on repeatability, predictive modeling, and causal explanation. This involves assuming that under like setups, we observe like dependence structures. Sometimes deterministic, sometimes probabilistic, so that similar conditions yield similar distributions of outcomes. Experimental design depends on this assumption, as scientists isolate variables to observe the effects of one on another. This presupposes that relationships between causes and effects are stable enough to be modeled, that nature exhibits uniformities, and that processes proceed consistently over time. Science's reliance on this assumption is not itself based on empirical demonstration. Instead, adopting some background of regularity is part of what it means to demonstrate empirically, to establish something scientifically. Philosophers since Hume have noted that no non-circular argument establishes that the future will resemble the past. Induction is indispensable, yet not justified by further empirical proof. This is part of the background regularity science uses rather than proves. If natural processes lacked regularity, if outcomes varied without pattern and effects didn't follow causes in any stable way, then prediction, replication, and explanation in fields such as physics would be unreasonable. In such cases, explanations might require broad generalizations with many exceptions or greater reliance on methods like surveys. Incidentally, this situation resembles some challenges in psychology, not because psychology lacks rigor, but because it examines subjects whose complexity and variability can resist strict causal modeling. You know, kind of like what one might expect if, for instance, free will existed. With that in mind,
free will is logically incoherent nonsense. Causes, and they go back all the way to the Big Bang. Does that mean we have no free will? People often ask me that. I find the question stunningly uninteresting. Of course we don't have free will. I already made a video about free will a few years ago. The whole story of the universe in every single detail was determined already at the Big Bang. These deterministic laws of nature apply to you and your brain because you are made of particles. And what happens with you is a consequence of what happens with those particles. Free will is an illusion. Physics tells us how the universe works, fundamentally, what the laws of nature are that everything obeys. And that includes the stuff that we are made of. So it includes us. Humans ultimately are big bags of particles, and we know the equations that those particles obey. And the laws that dictate the behavior of those particles are partly deterministic and partly random. This means that, to a big extent, what those particles do is a direct consequence of what happened earlier. That's the deterministic part. And then there are some quantum jumps on top of this, which are unpredictable and uncontrollable. And that's it. That's me, that's you, that's all of us. Some people think that once you combine all these particles to a brain, there must be something else that happens. Something that goes beyond what those particles do. Well, first of all, we have no evidence for that. It would actually be in conflict with the laws we have already established. But second, even if that was the case, if there was some new law coming into play with larger numbers of particles, there isn't even a theory for it that isn't also a combination of determinism and randomness. Other people think that they can somehow control the quantum randomness, But that's not how quantum physics works. That it's fundamentally random means that nothing controls it. And then there are those who throw around words like physicalism or scientism in the hope to make the facts go away. But the uncomfortable truth that science gives us is that human behavior is predetermined, except for the occasional quantum random jump that we can't control. And this is what humans are, for all we currently know. A lot of particles that obey differential equations, or as Roxy Music put it, more than this, there is nothing. This is difficult to make sense of, and I've struggled with this myself. It's a scientific truth that's hard to accept. I struggled with this a lot, because what's the point of doing anything if my entire life was written already in the initial conditions of the Big Bang? And to the extent that it wasn't, I can't do anything about it. Existential dread, brought to you by Physics 101.
Yep, this was actually a reaction video all along. That was Sabine Hossenfelder, a highly accomplished theoretical physicist with a real talent for communicating complex scientific ideas. This is not an example of that though. Science neither globally establishes strict determinism nor requires it. What it requires is stable dependence, deterministic or probabilistic, sufficient for prediction and replication. This claim that science has disproved free will seems to inadvertently assume that science can test its own preconditions and that law-governed nature straightforwardly entails the denial of agency. The first move is structurally dubious. No system can, using only its terms, justify or refute the assumptions required for its operation. For instance, when an experiment tests a hypothesis, it never tests that claim alone, but a package, the target hypothesis plus auxiliaries about instruments. The sensor is calibrated, the clock is uniform, what are called ceteris paribus clauses, assumptions that all else is equal, no interference, no contaminants, and initial conditions. The sample really is the stated temperature, the field strength is what the dial says. If a prediction fails, the data alone can't tell you which element is at fault, the hypothesis or an auxiliary. Even when fits are excellent, multiple models can accommodate the same information just as well. That's the Duhem-Quine point. Data underdetermine theory without background commitments. A simple example makes this vivid. Drop two objects in air and one falls slower. Did you disprove bodies fall alike, or did air resistance and measurement error spoil the test? And even when the data do line up, having perfect matches in data doesn't single out just one theory. Intuitively, if you plot a handful of points, you can draw countless curves connecting every dot, a straight line, a gentle arc, or a wildly wiggly path that threads them all. Choosing among these requires extra principles: simplicity, robustness to new data, mechanistic plausibility, cross-validation, not further observations of the same points. Those principles are methodological norms, not themselves empirical findings. They count as scientific only insofar as science employs them to interpret and appraise results. It's tempting to treat observations as neutral, unedited footage of reality, but observation is never just seeing, it's interpreting. Instruments don't hand over truths. They leave marks, readouts, and recordings that are, by themselves, only syntax, symbols without meaning. They gain meaning only when we apply agreed-upon rules for interpreting them. Calibration tells us how the scale maps to quantities, for example, how many counts equal 1 degree. A model tells us what that quantity says about the world, for example, why that count should be read as temperature rather than noise. With those in place, the marks become claims. Without them, they're just marks. In other words, instruments give us syntax, methods supply semantics. In other words, there's no such thing as raw data. If it counts as data, it's already interpreted, however minimally it may be. If it isn't interpreted, it isn't data yet. The second move crosses from science into pure philosophy. There's a methodological reason the dispute resists empirical settlement. Empirical methods register outcomes that actually occur. The counterfactual, the outcome under an option not taken, is never observed. Modern science compensates for this by inference, not observation. It uses methods like random assignment and structured models to estimate what would have happened under different circumstances. This works only if certain background assumptions hold. such as that the method for assigning conditions doesn't skew the result, that one case doesn't interfere with another, and that the right cause and effect relationships have been identified. This is powerful, but notice what it gives. Differences in outcomes between conditions, not access to the exact same person in the exact same situation doing something different. The libertarian claim could have done otherwise with the past and laws fixed targets a same-state counterfactual no method rightfully called scientific can test at all. The essential content of the theory is empirically out of reach. That's a methodological boundary, not a temporary limitation. Hence, a conceptual incommensurability. Science organizes observed outcomes. The metaphysics of agency turns on which counterfactuals we take to be meaningful and at what grain of description. And by the way, incidentally, free will needn't be defined as the denial of determinism. One might desire what is determined without contradiction. Furthermore, the domains of natural science and phenomenology lack a shared empirical basis, so concepts from one domain don't necessarily apply to the other. A separate discussion on this topic is available in the video The Empirical Incommensurability of Psychology and Neurology, which you can find on this channel. Nothing here denies that specific neuroscientific paradigms can forecast choices at above-chance levels in particular tasks. The claim is that such results neither prove global determinism nor resolve the question of free will. Anyways, so how did we get here? Why is Sabine Hossenfelder, a smart person who should know better, claiming that science disproved free will? And let's not single out Sabine. This overreach is common. Sam Harris, Jerry A. Coyne, Robert M. Sapolsky, Stephen Hawking, and others have all said in one form or another that science has shown free will to be an illusion. Where are they getting this? Even accomplished scientists may not fully understand foundational concepts in the philosophy of science, as their focus is on applying scientific methods rather than reflecting on the meaning of those methods or the assumptions that enable them. Philosophy of science addresses the conceptual foundations, logical structure, and epistemic limits of scientific reasoning, questions about the nature of science beyond merely how it's conducted. The scope of natural science is limited. Science interprets experience through logical inference. It depends on principles of entailment which are not derived from science but are prerequisites for it. No scientific experiment can determine whether a conclusion follows from its premises. Validity is a relation of logical form, not an empirical regularity. The principles of logic are not scientific findings, but requirements for interpreting any such finding. These principles don't inform the content of a scientific worldview, they enable that worldview to be coherent. The same applies to sentience, the capacity for experience. Observation implies sentience, as one must be capable of experience to observe anything. Science can describe correlations between changes in mental states and changes in brain states, sure, but correlation doesn't equate to reduction. Reducing experience to brain processes would require demonstrating how brain properties constitute mental properties. For instance, how the firing of C fibers constitutes pain. Nothing like this has ever been demonstrated at the relevant explanatory level. Science identifies patterns in observations and applies them to new cases, which succeeds for physical systems where behavior and structure are empirically accessible. However, experience and subjectivity aren't observable in the same manner. The content of experience is accessible only to the individual experiencing it, preventing the assembly of a dataset of first-person facts as required by scientific methods. Instances of experience can't be compared directly across subjects, as each is defined by a private perspective. Thus, generalizations about correlated behavior or brain activity are possible, but generalizations about experience itself aren't, due to a lack of direct empirical access. This limitation methodologically confines science to third-person descriptions, not first-person ones. Neuroscience tracks neural correlates of consciousness through methods like fMRI, which detect changes in magnetic resonance signals, interpreted as blood flow, then as neuronal activity, and finally as mental states in a sequence of interpretations adding layers of inference. Such methods don't disclose the qualitative nature of experiences, such as the feeling of pain or the emotional character of a specific memory. This is best understood not as a temporary technical issue, but as a structural feature of method. First-person content isn't directly pooled and compared the way third-person measurements are. Sentience, like logic, is not what science explains, but what makes its explanatory approach possible. Objections may claim that logic and sentience could eventually be explained as features of physical systems through naturalistic means, but accounts of logic inevitably employ logical inference. At minimum, the justification here is reflective rather than empirical. Likewise, third-person science presupposes first-person report to get started. Experience can't be reduced to third-person data without presupposing the first-person perspective that acquires such data. These elements aren't empirical facts to be explained, but the basis for empirical explanation. Science is a method for inquiry, but it's not independent of foundational non-scientific attitudes and beliefs. It relies on premises which can't be derived from it without circularity. These aren't subjects within science, they enable science. A common response to the resistance of entailment and sentience to scientific analysis is to conclude that they're not real. For instance, if science can't explain consciousness, then consciousness may not exist. If entailment can't be derived from empirical observation, then maybe it's just a social convention. This family of views, eliminativist or deflationary, has been advanced in philosophy. Daniel Dennett urges the dead obvious intuition about qualia, the subjective character of experience, be abandoned, and that heterophenomenology, a third-person science of reports, do all the explanatory work. But this is just a denial of consciousness altogether. If nothing irreducibly first-personal figures in the explanation, then there is, in the relevant sense, nothing it's like. And replacing that with third-person stand-ins changes the subject rather than explains it. To see the misstep, consider how reduction ordinarily treats the distinction between appearance and reality, and why that treatment fails for first-person facts. A stick partially submerged in water appears bent because of refraction, but it's actually straight. Once this is understood, the visual distortion can be set aside as a misleading appearance rather than a property of the object. Scientific reduction follows a similar pattern by distinguishing appearance from reality. What presents as seamless solidity is explained as atoms arranged in lattices whose electromagnetic interactions resist displacement and penetration. On that basis, solidity is redefined in microphysical terms and the seamless notion is dropped. Okay, no problem. But this method can't be extended to first-person facts such as consciousness, as in this case, appearance is part of the reality to be explained. Setting it aside would change the subject rather than clarify it. Hartree-Field developed nominalism about mathematics and a deflationary truth predicate aiming to preserve scientific practice while shedding commitment to abstracta and robust truth makers. On the deflationary view, saying that something is true is just a logical convenience for endorsement and generalization. It adds no content beyond what it asserts as a premise. Admirers see this as metaphysically hygienic, but critics reasonably worry that if truth is only a logical device, then the very entailment structure and measurement formalism science relies on lose their explanatory bite. Science's systemic success, especially novel prediction, approximate truth, and the norms of inquiry, needs a more robust notion linking theories to how the world really is, not just a device for rephrasing what we already assert. Besides, go ahead and try taking the deflationary stance seriously and watch what happens. If truth were to mean what the deflationists would engineer it to, answering why assert this rather than that becomes an awkward question to answer. Beyond re-endorsing the premise, there's no explanatory link between assertion and matter of fact to underwrite the value of accuracy, correction, and so on. The deflationist thesis isn't strictly self-contradictory, but it is pragmatically self-undermining. It depends on a truth-oriented practice of inquiry while denying truth any substantive role in explaining that practice's success. These conclusions put the cart before the horse if taken to undermine the preconditions of inquiry. Attempting to conduct science without entailment, without inference or consistency, or without sentience, without observation or interpretation, undermines science itself. Measurement and model building presuppose both. Denying them rejects the very foundation science requires. There's another irony to such eliminative and deflationary stances. The only things that justify belief in physics at all, by physics I mean not just the scientific discipline, but the domain itself, are logic, valid inference, and experience, observation. These are the framework conditions of having scientific evidence at all. Hence, no result in physics can coherently be taken to eliminate or replace them. Any purported finding that diminishes first-person experience or the norms of inference would thereby erode the very evidential standing it aims to bolster. At most, science can revise how particular experiences are interpreted, illusions, biases, or which inferences are appropriate under certain models. It can't entail such contradictions as consciousness is an illusion or validity is invalid without indirectly attacking the epistemic basis it presupposes and purports to strengthen. Put plainly, empirical conclusions answer to experience and logic. They can't replace them. No empirical proposition can both claim evidential support and deny the conditions of having evidence. Physics characterizes a restricted sample of what we responsibly take ourselves to know: quantitative structure and publicly observable systems and the presumed dependence relations that underwrite prediction therein. Many warranted claims lie outside that representational scope. Entailment and the first-person character of experience doesn't depend on physics, rather our warrant for believing physics-pertinent claims depends on them. We infer the domain of physics from our prior acquaintance with inference and experience together with methodological norms, simplicity, robustness, and variance, that aren't themselves deliverances of physics. Scientism, the doctrine that only the natural sciences provide genuine knowledge, or that every meaningful question must be answered by their methods, mistakenly reverses this order of dependence by treating a late specialized method as the measure of all knowledge. This isn't a demotion of science, but a boundary claim. Within its domain, it's unrivaled. Beyond it, and much is beyond it, other forms of warrant do the work. Back to Hossenfelder's stance. Science has disproven free will. Disproven what, exactly? Causality is a standing assumption of physics. It underwrites prediction. It doesn't decree a philosophy of agency, and evidence answers to logic and experience, not vice versa. Free will is an experience of weighing reasons, of being able to do otherwise under a description. Announcing that science has disproven it is on a par with declaring that spectroscopy disproves the color green because it identifies 500 to 565 nanometer wavelengths of light. That discovery tells us how green's counterpart shows up in physics. It doesn't prove that no one sees it. Once you've seen how eliminative and deflationary moves try to protect science by shaving off its own preconditions, experience, logic, truth, the free will overreach looks less like an isolated mistake and more like the same ethos at work, a drive to convert methodological success into a universal metaphysical verdict. If we're prepared to deny the data of experience or thin truth to a mere device, it's no surprise that we then announce on the strength of models and correlates that free will has been scientifically abolished. The pattern is the point. Having trimmed the fact to fit the method, it's easy, but erroneous, to claim the method has thereby trimmed the fact itself. It's doubly unfortunate that this overreach is often received as grim enlightenment. Even Hossenfelder has said that this is knowledge she would rather not have, and many readers of hard determinist popularizations report discouragement or a hollowing out of meaning. But that bleakness isn't the price of facing a hard fact. It's the predictable consequence of a false belief that science has established more than it can. Despair here isn't courage before reality, it's an avoidable error about what science does and doesn't show. A quick aside, the apparent temptation which afflicts so many scientists and scientifically minded people to dismiss philosophy as an inferior surrogate for science overlooks the inherently philosophical foundations that science depends on. Attacking philosophy in defense of science inadvertently undermines science by denying its presuppositions. Without these presuppositions, no scientific method remains. When scientism drives philosophers out of the room, it doesn't remove philosophy, it just hands it over to whoever's left. The result isn't a purified science, but scientists doing philosophy, sometimes well, often not, while mistaking methodological success for a license to legislate on meaning and truth. That's a loss of intellectual division of labor, not a gain in rigor. Better to keep philosophers in the loop, precisely so science can remain answerable to the conceptual standards that make its findings worthwhile.
I should add here that it's not like I'm saying something new. Look at the writing of any philosopher who understands physics and they will acknowledge this.
Did you get that? She's saying there's two kinds of philosophers, those who agree with her and those who don't understand physics. Preemptively classifying dissent as incompetence so that objections may be interpreted as proof of ignorance. Got it. Guess I'd better stop providing counter-arguments or I'll look stupid, right? Even granting that I don't understand science, that I'm an idiot, and that I was thawed from a glacier shortly before recording this video, does nothing to establish that the methodological assumptions of science are equivalent to scientific evidence. Explanations of why someone believes or what kind of person believes are no substitute for arguments about what is believed. Explaining a belief's adoption isn't the same as refuting it. You only believe the Earth circles around the sun because you're a sun worshipper, therefore the sun circles the Earth, is exactly the kind of leap being made. Fine. If philosophers are disqualified to speak about science for disagreeing, maybe we can at least meet on her turf in philosophy. As it happens, she offers a purely conceptual argument. Let's hear it.
The reason this idea of free will turns out to be incompatible with the laws of nature is that it never made sense in the first place. You see, that thing you call free will should in some sense allow you to choose what you want, but then it's either determined by what you want, in which case it's not free, or it's not determined, in which case it's not a will.
That was supposed to be a dilemma. If free will is determined by what you want, then it's not free. If free will is not determined, then it's not a will? I'll address each horn in turn. First horn. If will is determined by what you want, it's not free. On the ordinary concept, to act from one's will is to act according to what one wants, or judges, intends, endorses, etc. So will is determined by what you want is more like a tautology than a contradiction. It's like denying my head exists because two objects can't share a location and the spot my head occupies is already occupied by my head. The determination here is analytic identity, A equals A, not the external determination that might threaten agency. A further flaw is the notion of determination, which can degrade into the identity schema A implies A. If the intended point is that a thing is determined by itself for its identity, that's a non-standard notion of determination. Second horn. If will is not determined, it is not a will. This doesn't follow from the concept of will. Being determined is not entailed by being willful. Absent an argument to that effect, if it's not determined, it's not a will is simply an unsupported and apparently false assertion. In conclusion, Hossenfelder's dilemma is unsound. The first horn mistakes constitutive identity for external determination and therefore doesn't undermine freedom. The second horn assumes, for no apparent reason at all, that will entails determination and thus fails. So the dilemma doesn't establish that free will is impossible. What's offered is the appearance of an argument, a dilemma, without the corresponding semantics. This is exactly what I was talking about in that aside. Let scientism chase away the philosophers, and this will be the level of philosophical qualities supplied by their replacements, bare assertions mimicking philosophical cadence. That took a personal turn, so I'd like to state for the record that I like much of Hossenfelder's work. I bought Lost in Math, even though I happen to work in a library and could have just checked it out for free. This isn't a hit piece. It's just a pushback on a claim that, as we've seen, definitely isn't unique to her, but still for sure steps outside science's lane. Given the confusions in play, it's useful to close with a concise explanation of an argument for the relevant concepts. This is what can be done with more thoughtful conceptual analysis and an argument that follows from it. A fact is necessary if and only if its denial entails a contradiction. Unless otherwise noted, necessity below is logical. This explains the impossibility of drawing a circular triangle. The concept triangle, a figure with 3 straight sides and corners, conflicts with the concept circular, a figure which lacks straight sides and corners. It's not just that no one's drawn such a shape because it's really difficult to do, the attempt is impossible from the outset for its incoherence. No contradiction, no prohibition. Determination can be understood as the relation by which one fact, B, makes another, A, inevitable, relative to a specific background. In the strictest sense, B determines A when B's truth renders A's falsity logically inconsistent. Some facts follow necessarily only within the constraints of a particular system of rules. For example, in the standard version of tic-tac-toe, a win is determined by drawing 3 of the same symbols in a row according to the game's rules. But those rules themselves aren't necessary. They could have been different. A variant requiring 4 in a row on a bigger grid is entirely coherent. In such cases, what is determined is a consequence of a stipulated framework, and the framework itself is open to modification. We may distinguish between 3 kinds of modal status. You've got logical necessity and possibility, that's what must be on pain of contradiction. Nomological necessity and possibility, what must be, given assumed laws of nature and relevant physical conditions, and counterfactual possibility, coherent what-if alternatives, possibilities that are not logically necessary but are intelligible and meaningful. Determinism is a claim about nomological necessity. Given the actual laws of nature and the complete state of the world at a time, only one future is physically accessible. Put carefully, determinism asserts, from the actual laws and past, a single future follows. It does not assert, only one future is logically possible. So determinism narrows possibilities relative to the laws and past, rather than collapsing counterfactual space without qualification. Determinism is conditional, not categorical. In short, physics gives if-then, not must-be. Determinism is explicitly conditional. It depends on the laws and constants that in fact obtain, and on the particular boundary and initial conditions of the universe. But these features, the laws, the constants, the conditions, and indeed the universe itself, are not themselves logically necessary. Different physical laws, or initial states, or the failure of these facts to obtain, does not entail contradiction. Thus, nomological necessity is grounded in a broader background of non-necessity. Here's the claim. If a fact P isn't logically necessary, then there's a counterfactual possibility in which P is false. If logic doesn't compel it, a counterfactual permits its contrary. Step 1. Assume P isn't logically necessary. Logic doesn't force P. Step 2. If logic doesn't force P, then not P doesn't produce a contradiction. Otherwise, P would have to be necessary after all, so the description not P is coherent. Contradictions close doors, coherence keeps them ajar. For example, there are exactly 7 stars isn't logically necessary, so there aren't exactly 7 stars is coherent. Step 3. Counterfactuals range over coherent, contradiction-free alternatives to the actual world. Any fully coherent way things might have been counts as a counterfactual possibility. Here's the conclusion. Since not P is coherent, and counterfactuals admit coherent alternatives, there is a counterfactual situation in which P is false. Hence, from P's non-necessity, we obtain a counterfactual possibility where not P. No contradiction, no prohibition. So, global necessitarianism, the thesis that all truths are logically necessary, is untenable. And, by extension, the view that reality is exhausted by nomological necessities mistakes conditional law relative constraints for unconditional logical ones. Of course, physics never supplied global necessitarianism anyway. Scientific theories express conditional regularities. If these laws and these conditions obtain, then these outcomes follow. Physics gives if-then, not must-be. Elevating this to the claim that all truths are logically necessary is a shift from scientific method to metaphysical stipulation. This distinction is crucial for understanding the scope of agency. Many actions have logically consistent contraries. There's no apparent contradiction in asserting that a person could have taken a different route, declined an offer, or never have been born had their parents made different choices. Could have done otherwise is a logical space, not a logical error. Whether such alternatives remain open, while holding fixed the past and the laws, is what divides libertarian and compatibilist accounts. But nothing in scientific practice upgrades nomological constraints to logical necessity, so dismissing agent-level alternatives as incoherent goes beyond what physics warrants. As tic-tac-toes obtaining rules and structures stand among non-obtaining but contradiction-free alternatives, thereby evidencing freedom at the level of game design, why deny freedom at the level of play in where a player may draw an X or O? Demanding logical necessity of agent-level alternatives is an unjustified standard shift while the modal profile of world-level facts is non-necessary. This stance parallels the historical Imago Dei motif but holds independently of its classical commitments. It may be rejected without consequence for those commitments and vice versa. In conclusion, logical necessity rules out contradictions while physics identifies merely conditional necessities relative to features of the world whose contraries entail no contradiction. If such contingency is already present at the ground level of physical explanation, there is no principled reason to forbid acknowledging its possibility at the level of agency. Free will concerns the availability of agent-level alternatives that are not logically contradictory, even if they are causally constrained to some degree or another. global necessitarianism is incompatible with any nomological account, including physics. Determinism, understood in its standard nomological sense, does not entail necessitarianism. However, global determinism, construed as a logically necessary fixation of all truths, collapses into necessitarianism and is therefore likewise incompatible with a nomological account. Again, that includes physics. Moreover, if exceptionless necessitarianism is presupposed, free will becomes unrecognizable by definition. If only contradiction-proof facts count as real, then no counterfactual alternative, no genuine could have done otherwise, can be acknowledged. That standard isn't established by scientific practice. It's a philosophical stipulation that demands logical necessity where only physical regularity is at issue. Like the video and subscribe. Or don't. It's your choice. You can do whatever you want.